Hi, my name is Manish Gupta, and in this video, I'm going to talk about unfairness in computer vision models. This is a paper about a new data set from Meta AI called as FACET, and this data set is around answering this basic question: Are computer vision models biased? Right? In fact, there are a bunch of such interesting questions that the paper focuses on. Are models better at classifying people as skateboarder when their perceived gender presentation has more stereotypical male attributes? Do models struggle to classify people with tattoos? Do models perform better for people with curly hair who appear to have perceived lighter skin tones than to those with perceived darker skin tones? Of course, we are talking here about vision models, models about classification, segmentation, person detection, and so on. Are open vocabulary detection models better at detecting backpackers who are perceived to be younger than older? Do standard detection models struggle to detect people with whose skin appears darker? Right? Are these problems even magnified when the person has coily hair compared to straight hair? Do performance discrepancies differ across detection and segmentation tasks? Those are the kind of questions. I mean, I think the bias was sort of very clear in these questions themselves. And with that aim, Meta created this FACET dataset. The dataset basically contains several images which have been labeled the way you see there. So there are about 32K images labeled with 50,000 people in them, right? And these people belong to 52 different person-related classes. These classes are all listed here. So there are lawman, laborer, boatman, guard, backpacker, basketball player, tennis player, and so on and so forth, right? Um, so what has been annotated is a bounding box around the people in these images. There is also information which is annotated about the perceived skin tone, perceived age. So remember, these are perceived. Of course, you don't know what is the exact age of the person, but these are perceived age, perceived skin tone, perceived gender, and then what is the brightness level of the photo, additional attributes like whether there is a tattoo or facial hair, visibility, like is the face visible, torso visible, or so all of those things, right? Um, there's also that basically is the level of occlusion part, right? And there's also things like what is the main category. So the category is guitarist here. Well, there's also secondary category which is also marked, which will be maybe a singer in this particular case, a musician in this case, right? Uh, then there is also hair color, so and the hair type, so which are all marked in this data set. The way this data set is created is by starting from a whole bunch of images. So they start from a lot of images from the segment anything 1 billion benchmark. So from these images, they essentially take captions and they tokenize and limitize those captions. So a person is playing a flute at a concert basically gives you those captions, right? Or those important words from the caption. Right? Now you also take the category. So for example, in this case, the category was guitarist or any of these categories. You go to WordNet and try to figure out other WordNet concepts related to those categories. So you get relevant terms, using WordNet synsets and similar concepts, and then you compute the overlap between these WordNet synsets for categories and the captions, and that basically gives you an overlap score between lemmas and word lists. And then what you do is to basically output a sorted list of categories that are likely in the images. So the idea is that they took only those categories. Of course, they start with a very large number of categories, but they take only those 52 categories which are listed here. Why do they choose 52? Because these categories appear both in WordNet as well as in ImageNet. So the images that are taken here are not just images in the benchmark, but also those images which are there in ImageNet 21K. Right? So popular categories across the two are the ones that are reflected in these person categories. Now, the way the data set is created in general is to essentially have four different stages of dataset creation. The first stage, basically, they found those images which contain those images from this segment, anything 1 billion benchmark dataset, which contain between 1 to 5 people. So more than 5 people, they ignore those images. Less than, I mean, of course, there should be people, and then those people should match one of the 52 categories, right? So if they match one of the 52 categories, then you basically again, manual annotators are asked to draw bounding boxes around each person and label each box which of the category it belongs to. And then stage 3, you annotate the perceived skin tone. Skin tones are actually taken on a 10-point scale, also called as the monk skin tone scale, right? So after that thing is done, in stage 4, you annotate the remaining attributes as we discussed: hair color, hair type, eyewear, headscarf, tattoo, and so on and so forth, right? So several kinds of things are labeled. We discussed this on the previous slide, but there are labels around gender presentation. So what is the perceived gender? It's female, male, non-binary, or unknown, right? Skin tone follows the Monk skin tone scale. Age, younger, middle, older, or unknown. And as you notice, there's a good distribution across different things. In fact, for skin tone, essentially it's like more or less it's like a normal distribution with a lot of instances around 4 to 6 in that census. And then there are instances at the extremes, right? Hair color, there are different kinds of hair color as you see, and enough instances across all of them. Hair type, again, there are various different types of hair types. Lighting conditions, 5 different kinds of lighting conditions, visibility, minimal, face or torso, and then other additional attributes like cap or tattoo or mask and so on, right? So now, how do they use this data set? Well, they use this data set to identify bias in classification, person detection, segmentation, open vocabulary detection, and also visual grounding kind of problems, right? These are all vision related problems. And the way they measure the bias is by measuring something called as disparity. So if you have a model F, right? So basically they use different kinds of models for different settings. So for classification, they use clip VIT model. For person detection, faster RCNN model. For segmentation, mask RCNN model. For open vocabulary detection, DATIC model. And visual grounding, they use the OFA model, right? So let's assume that you have a model F and your performance metric. For example, recall is one of those performance metrics, but different kinds of methods will have different performance metrics. Like for example, AUC score, or not AUC, sorry, the IOU score, average recall score, and so on and so forth, right? So different kinds of metrics. So if you have some metric, some model F, and you have a bunch of concepts C. So the concept could be, for example, teacher, right? And an attribute label L, and a set of images. So, a set of images like ILC, I mean, associated with that label. So then disparity is basically considered as recall for a particular label minus the recall for the other label. Okay. A concrete example is here. So if you wanted to measure the disparity of between the younger and older people for the concept teacher. So you want to predict, you want to essentially classify somebody as teacher, and then you want to figure out, hey, what is the disparity if you consider younger people versus older people, perceived to be younger versus perceived to be older people. In that case, disparity is basically just given as recall of the classifier basically being able to predict an older person as teacher versus younger person as teacher, right? So that's that, given images in that class. Okay. So what is observed is large levels of disparity, large levels of bias, right? So essentially what you see here is male minus female. This is female minus male. So this is basically results for classification setting. So for gardener, it is more likely that the model will do well on male gardeners. And similarly for dancer, the model is more likely to predict the person as dancer accurately if the person depicted in the image is perceived to be female, right? So that's that. Now on person detection, essentially, we basically look at bias from a skin tone perspective. And what you observe is that typically you see the scores are much better for lighter skin tones and lower for the darker skin tones. And this is basically consistently observed across different IOU values for average recall, right? So what is observed overall is that for person detection with faster RCNN model, Resonate 50 FPN backbone, it is observed that the darkest perceived skin tone has the lowest performance actually, right? Now, if you look at open vocabulary detection task and open vocabulary detection task and the visual grounding task, and you again, and this is a intersecting dimensions kind of analysis where you have the age class as well as the person type. So backpacker, trumpeter, or drummer, you clearly observe large disparities, right? For example, for backpacker, there is a good probability that you will be able to do good open vocabulary detection with a high probability with a good accuracy, for younger ones versus older ones. So the disparity is super high, right? So disparity has like 15-point gap for backpacker class in mean average recall, right? Similarly, you see disparities across visual grounding as well. So for example, for older people, older people are more likely to be accurately predicted as gardeners rather than younger people, right? And this is observed across multiple types. In the paper, you will see for different types. Here, I've just shown for 3 different categories of people, but you will see in the paper that these disparities are present across almost every type. So that's that. So in summary, in this video, I talked about this interesting data set, FACET, 32K images, annotations for 50K people, 52 categories, 13 personal attributes marked on them. And I did talk about a few of those disparities with respect to a few attributes and intersecting attributes, but in the paper, you'll find many more. And in fact, the dataset is pretty rich. So you can actually look at the dataset and probably discover more disparities. So we did discuss some of the disparities in the classification, detection, segmentation, visual grounding tasks. They do exhibit performance disparities across demographic attributes and intersections of attributes. These harms unfortunately suggest that not all people represented in the datasets receive fair and equitable treatment for these vision tasks. The dataset is publicly available here. That's it. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.